Hey guys, this is Ed from Mission Impossible. Welcome back to my Atari programming series. This is episode 11. We're finally going to do some scrolling, I promise. Okay, let's get into it. This is where the game is going to actually seem like a game. So the way we're going to be doing this is as I was saying, we need to modify the display list in real time. So we're going to create some functions to do that. So in order to do this, we're going to need to be able to modify it so that when we're going left or right, we need to change the memory location to be, -2 or +2. And then if we're going to go up and down, we need to go decrease by 80 or increase by 80. Remember, the line length is the 128 characters, which is hex 80. So let's first handle the addition. And I've worked through already on how to, in notes here, the way I implemented it. I've seen stuff online, they implemented it slightly different. This seemed to be a decent way to go. So we'll see how this goes here. So I'm going to create a procedure called scroll RD, which is right and down. So what we're going to do is we're going to say byte and A. That means we're going to be using the accumulator for this. And we're going to say use reg. That's the register, okay? What this means is whatever we pass in here is going to be stored automatically by the function into this accumulator, okay? So we're going to need to deal with that in some way. And to do that, I'm actually going to create a temp variable. We're going to use 0 page again. Now, we don't have to use 0 page, but it just makes so much easier. It makes it so much easier to store stuff. So I'm gonna create a temp variable here, and I'm gonna store whatever the accumulator has, whatever I'm passing in as TMP. Okay, so we're going to be storing that data into 92. Now, what we're going to do here is we're going to create 2 loops. Okay, actually we're going to create 1 loop with two indexes on it. We're going to do 16. We're going to do LPX4, and I'll get into why we're doing that in just a second. We're going to create the loop, and we are going to clear the carry. Now, in this case, we're going to actually really want the clear carry here for a very specific reason, and I'll get into that. But we're going to load in, so the setup screen .dlist. So that's, if you remember in NADS, this is how we reference a variable in another function. And we're going to do an offset of X. Okay, so we're going to load in at this dlist, which is, let me go ahead and pull this up on the right here, just so you can take a look at it. So we're going to start at an offset, this dlist of, we're going to want to start right here. So 0, 1, 2, 3, 0, 1, 2, 3, 4. So this is where we want to start, okay, this 0, 0. And what we're going to do is we're going to want to modify this, and we're going to add whatever our value is. So we're going to say ADC temp. We're going to add whatever's in temp to the accumulator, okay? And so right now we're going to be loading in 0, 0. And let's say we pass in 2 to go 2 to the right, say. And depending on how you look at it with scrolling, it actually will be scrolling left if you move right, but whatever. The point is here that we want this 0, 0 to go to a 0, 2. And so if we're passing in 2 to our scroll RD, then we're going to add 2 to that variable. Now, this is all well and good. The problem here is that once we want to go more than the 1 byte can hold, we're going to need to increase this one as well. Okay, and that's what we're going to do next. So we're going to say, so we haven't stored it yet. So let's go ahead and store, setup screen, dlist, comma X. So all we're doing is loading it in, add temp to it, and store it back. Okay. Now we're going to increase X, increment. I always say increase. increment x. And now we're going to say, we're going to load in again, .dlist.x. And then we're going to do an ADC temp. Actually, no, I'm sorry. We're going to do an ADC of 0, and then we're going to store it back in. And I'm going to explain how that works in just a second. So at first glance, this may look like it's not doing anything. If you're adding 0 to this, what's the purpose? Well, the purpose is the fact that we have the carry flag involved. So that means if we have added a number to this here and it overflows, the processor knows that you've overflowed that register, and it can say, we're going to set the carry flag then. So that means what we're going to do is we're going to say whatever it's been overflowed, we're going to add 0 plus the carry. So if it didn't overflow, this will do nothing. Okay. But in the case where it did overflow, it will actually increase the high byte of this. Okay. So now we're going to go to the next. So we're going to say we're currently on, say, this one right here. We're going to want to go from here and to the next one. So we're going to do inx twice. So increment x twice. So now we're sitting right here. Okay. And now what we're going to do is we're going to decrement y, because this is how many times that we're going to be going through this loop. Okay. And so we're going to say decrement y, and then now we're going to do a B&E loop. So basically this is what this is going to do, is it's going to go through this X amount of times. And so how many lines do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We actually don't want to do 16. We want to do 12. Okay. And yeah, so we're going to go through the loop, and now we're going to do RTS and pointer. That's how we scroll right and down with this function. Now we're going to get into when we're going to call that in just a minute. But the idea with this is we're going to be able to add 2 to this, and we could also add 80. We could add a weird number if we want, but it's going to be either 2 or 80 in this particular case. So that handles scrolling to the right and to the down, but now we want to do the reverse. And you can probably figure out what we're going to be need to do with this. But let me go ahead and copy and paste, because it's going to be very similar. Not so similar that I'm going to want to combine them into one. I looked into it, but it just didn't seem like it was going to be good. All this stuff is the same. The only thing we're going to be doing is we're going to be basically doing the same thing for this, doing subtraction. So this SEC is instead of the carry, it's going to set the, let's see here, 6502. Let's see what SEC stands for again. Set carry. Okay. So basically this is what we need to do when we're doing subtraction. We want to set that at the beginning. It's similar. It's the analog to when we're doing a clear carry, when doing addition. So what we're going to do is we're going to do an SBC. So subtract with carry and do an SBC. Okay. And we're going to go through the same amount of time. And that's all there is to doing that. Okay. Now we've done our scroll up and our scroll up and left and our scroll right and down. They look very similar, but they are, different in that they're one subtracting, one's adding. Okay. We have our functions, but we have nothing calling them yet. So the next thing we need to do is we need to change this. So this jump star, which means it's just constantly doing that over and over in an endless loop. We want to change this so that we have a game loop. Okay. So I'm going to call it game, original there. But this is going to be our main game loop. And what we're going to want to do is we're going to want to start using a controller. This is where, I always say this, but this is where it gets fun. Okay. So in order to use the controller, it's actually pretty simple. What we're going to do is we're going to need a couple locations for this. And it's actually just one. The Let me find it here. In our hardware, it's just going to be stick 0. And it's going to be at location 027B. Okay. 027B. And I'm going to just go ahead and put it in here as a, let's see, joystick 0. Okay. We're only going to use one joystick for this game. As far as I can think of right now, we could get into some craziness and have 2-player action. But for now, one joystick. And let's go ahead and put in the place for this trigger as well. So that's called strig. So S trigger 0. And that's going to be at 0284. So let's go ahead and put that in there. 284. We don't need it just yet, but we will eventually. Trigger 0. Okay. And in here, what we're going to want to do is we're going to want to look at what is in that the stick location. Okay. And what we're going to do is we're going to compare that with a couple of values here. And I'll show you what we're doing here. Okay. So we're going to load in stick 0. And the way we can tell what direction we're going is there's a certain bit pattern that happens on a joystick. And the way it works is there's 4 bits that are being used. The first bit, if it's flipped, is up. The second bit is down, and then left, and then right. And so what we can do is we can actually create some variables to make this maybe a little bit cleaner and say, let's go with, I guess I'll put them up here. Let's go with, we're going to say left. Let's start in the correct order here. Let's do up. And we may want to put in a, let's go stick up. Okay. And what we're going to do is we're going to say percent so that we can do bitwise stuff. 1, the first bit. Okay. And then we're going to say stick down. We could do, I'll go ahead and spell it out. 0010. Okay, let's go ahead and clean that up a little bit. And we'll say stick left equals, so and stick right. Oh, I was off by 1. Okay. Let's make sure I'm on the right. Yep. Okay. Okay, so now we have variable set up so that it's a little cleaner. Okay. And now all we need to do is we need to just do an AND on whatever's located in, whatever's in the accumulator at this point. So let's go ahead and do an AND, and we're going to say, let's just look the up thing. So we're going to say and stick up, and we want to make sure to use the pound sign there so we want to know the actual value, not a memory location. And stick up, we're going to want to call this up and left, and we want to pass in, in the case of up, we want to pass in 80. And so what we're going to need to do here is have a section down here called up, and we're just going to do a verify here. So we're going to say scroll left and up, and we're going to say 80. Okay, we're going to pass in 80, and now we're going to jump to game. So what that's going to do is it's we need to call it BEQ up. Okay, so that's going to say if this and is if it comes out to be a 1 value, then we're going to say if it's true, basically it's going to go down to up, and it's going to do a scroll LU and then jump back to game. And now we need to do that for all 4 of our directions. So I'm just going to go ahead and copy and paste this for each one and then do some changing. Okay. Now we need to load it in every time. Now the reason why is because this and actually writes back to the accumulator. So that's a problem. If you want to, if you don't load it back in, it's going to overwrite the data that you had in there. So that's not what we want to do. So we're going to have to load it, every time. So we're going to say, okay, so we're going to say stick down, and we're going to go to a branch of down, stick left, stick right, and then branch left, right. And we're going to do a similar thing down here. Okay, and we're going to do up and down. And that's going to do, instead of DU, we're going to say RD for right and down. And we're going to go 80 as well. Now for left, we're going to do just 2. And we're going to say left and up. That's good. 2. Okay, and then right, we're going to say right and down, 2. Okay. And then, so it's going to call these scroll functions every time the stick is pointed in that direction. Okay, so let's see how this works here. Undeclared macro, scroll LU. What did I script? Oh, LU versus UL. Okay, let's change that. UL. I did UL and RD. Oh, that's bad. I'm gonna change it to LU. Okay. LU and UL. Okay. Had it right the first time. Okay, well, compile. It's assembled. Now, oh, interesting. Wasn't expecting that. Okay, then. We got some scrolling going on when we're not expecting it. What did I mess up here? And we'll stick up and we'll stick down. What did I do wrong? Oh, I know why. Well, no, that's not right. But we do need this. We do need a hex of 80, not 80. But that's not actually the problem. So what's happening is, oh, I know what the problem is. Okay, what's happening is that we forgot a line here. It's going through here, all this, and there's nothing stopping it just to go right into up and then jump game. So what it's doing is it's scrolling up like crazy. We need to put a jump game in here. So basically, if the stick isn't being moved, just go through this every time. Okay, let's try it now. Let's see if this is any better. Okay, cool. We're not getting scrolling like crazy. So I'm just going to go ahead and scroll down, or just kind of go down and see if it does anything. Okay. Joystick is not working. Why? What did I do wrong? Well, it's doing something. Let's try again. That's weird. Interesting. Oh, I'm pressing a button and it's scrolling. Weird. Interesting. I'm thinking I messed up on my memory locations or something, because that is weird. Either that or my emulator thing is messed up. That doesn't make sense. Okay, let's take a look at the hardware. Stick 0. Let's verify that I'm in the right location. Stick 0 is 0278. Not B. I have my notes on another computer over here. And that looked like a B from over here. And that would be wrong. I think what it is there is a button configured as a trigger there. So let's try that again. Okay. Now I am moving around. Now keep in mind is it's moving really fast. So if I go up and down, it's scrolling through memory, which is kind of cool actually, it's kind of neat. You can actually walk through memories, so to speak. And we'll try to prevent that, but I'm just going left and right. It's kind of neat. You can kind of see this random memory. Yeah, if you ever wanted to see what like some of the memory locations look like. So this is kind of interesting. Must be locations that are changing. So it could be like the real-time clock or something, who knows. But yeah, so it's actually kind of neat. You could actually do some pretty cool stuff with this. That'd be a whole other exercise. But the bottom line here is we need to slow things down. But the scrolling is working. So what we need to do now is we need to put in a delay. And the way we're going to do that is we're going to be using the real-time clock. And I'm going to explain how that works here in a second. Mapping the Atari, and we're going to use RT clock. Okay. And we can see that it actually has some good info here on how to use this. Okay, so there are 3 locations for the real-time clock, 12, 13, and 14 hex, okay? And the way this works, and feel free to read all of this, but to kind of put it into perspective what you're going to need to do, to break it down here for you. What it is there's 3 bytes in here that will constantly go up. And the idea is the 14 will go the fastest. And what it's doing is every time there's a vertical blank, it's going to go up by 1. And so it's going to keep going up. Now, the deal is that means that's going to go up every 60th of a second, because we're dealing with, at least in NTSC, on a PAL machine, it would go up 50th of a second. But on an NTSC machine, it's going to go up 1/60th of a second every time that increases. So what we can do is we can use that to our advantage. And we can say, okay, we're going to take a look at what it is, and we're going to compare it and say, once it's gone up X amount, then we can stop. So the idea here is that we may want to have like, a half a second or a tenth of a second type of delay. And this is going to come in handy for a lot of things. We probably will want to use this for a lot of delays kind of things. So what I'm going to do is I'm going to create a function in here, procedure called delay. Okay, so I'm going to call proc delay, and we're going to want to pass in how much of a delay we want. So I'm going to just also use the accumulator. Now there is a way to use variables, but I have not gotten it totally working yet. So registers it is for now. Okay. Actually, I'm going to use X instead of A, because we're going to need that is a variable, or we're going to be using the X register in our loop. Okay. So what we're going to do is we're going to say start, and we're going to load in the real-time clock. Now I need to add something to my hardware. Now, if you remember, we saw it was 12, 13, and 14. Now, I prefer, when working with these kind of things, to say, so we're going to say 12, and that's the first location. So we could use RT clock plus 1, plus 2, that kind of stuff. I'm not a big fan of that. What I would prefer to do is something like, I prefer to do this. I'm going to say RT clock 0, RT clock 1, RT clock 2. And just so that, we can easily use any one of these. Actually, I don't think I mentioned what's going to happen here is first the RT clock 2 is going to go up, and then once that's clicked up 1, it's going to increase RT clock 1. And then once that's got so it's just going to have these basically rotating dials, if you will. So really what we're going to care about is this RT clock 2, or the 14, or RT clock plus 2. But I like this. So we're going to use RT clock 2, And so keep in mind, we're only going to be able to do something in whatever 255 divided by 60 is. So it's like 4 something seconds. For now, I think that's fine. We could get in, if we want a longer delay, we could definitely take that into account by using more of the real-time clock registers, but the first one's just fine for now. So what we're going to do, we are going to load in whatever that currently value is, okay? And what we're going to do is we're going to want to wait to see when that changes. So we're going to create a new label called wait, and we're going to say compare with RT clock 2. And we're going to say BEQ wait. What that means is it's going to wait until it changes. If it's the same, it's going to just go back up to wait. So this is going to happen constantly. So it's only going to happen, actually change every 1/60th of a second, which is a long time as far as the computer is concerned. So once that's happened, what we're going to do is we're going to decrement X, because remember, we're going to be storing whatever we pass in here into the X register. And so we're going to decrement that. And we're going to, every time it isn't 0, we're going to go back up to the start. Okay. And so it's going to go through X amount of times. So now we can do a RTS and end P. Now what we can do is we can add a delay. Now we can add a delay in here, or we can add it in the scroll. Okay, so I'm actually going to say let's add it in our delay here. Let's add it in each one of these sections here. Well, actually 4 lines versus 2. But just scrolling, we may not want to have delay every time. So let's just put it in this loop here. We could always change however we want. So let's try a value of, say, 10. Okay, so that's going to be 10/60ths of a second, which would be a 1/6 of a second. We can play around with that, but let's try this to start and see how that is. And now there's probably a nicer way to do this so that we can put it only in one spot. But we could jump down to another value, and it's fine though. We'll just leave them in there. So let's see how that goes. Okay, now we can move around. So we obviously have not done anything with collision detection, but we can now walk around on our map. So there we go. This is definitely something where it's like, this is now a game. I can do this. This is so cool. Collision detection is actually going to be really easy, and we'll cover that next time. But this is a lot of fun. Oh yeah, so I might as well show it. You can go through walls. Okay. And we can play around with it if we wanted to change the amount of delay. So if we want it to be quicker, so if we wanted to be able to run, we could even do something like set a speed if we wanted, and that way we could delay that. And if we wanted to have a run function, we could. So that would be something that'd be super easy to do. For example, like if we wanted to implement it so that if you hit a button, it would run. We don't want to do that probably for our game, since one button's going to be a bit tricky to use. But if we wanted to run and we had to set a button, we could totally do that. We just change that delay. Well, let's see how it goes now. So now we're jamming. Okay, that's cool. So yeah, well, there you have it. We now have scrolling working. We have a new map, and we can scroll around, and yeah, so here we go. Thanks for watching. If you enjoyed the video, be sure to hit the like button. If you'd like to see more of this kind of content, be sure to hit the subscribe button and ring the bell. I post new videos all the time, and I wouldn't want you to miss any. If you'd like to see more of this series, be sure to click up here. And if you'd like to see something else, be sure to click up here. As always, see you in the next adventure. Take care.